Hello, and thank you for viewing this presentation, which was given at the EUCNC 2026 Workshop 12, describing MARE activities on advanced network digital twins for AI-driven 6G systems. This talk will present how MARE uses a network digital twin-based sandbox to both support incident analysis and the pre-assessment of remediation actions before they are deployed into operational environments. The main idea is to make 6G ecosystems more reliable by combining programmable security functions, orchestration and validation across simulation, emulation and real infrastructure. The overall MARE objective is to enable a reliable 6G services provisioning platform through a security plane built from open and programmable security functions. However, both proactive and reactive security approaches face an accuracy challenge, because estimations and predictions can be wrong and wrong decisions can degrade performance or even make the situation worse. This is why MARE introduces a smart pre-assessment ecosystem, based on the no action without preliminary testing principle and the what-if loop, so that candidate actions are analyzed before production deployment. We highlight the sandbox idea inside the broader MARE architecture. MARE is organized around the cybersecurity core, the abstraction layer and the interface layer. The cybersecurity core includes the Security and Privacy Engine, SEPE, providing .design, security function composition and adaptive orchestration, as well as the pre-assessment testing environment, PASTE, providing the testing environment management, as well as pre-assessment and validation. The sandbox is therefore not an isolated add-on, but a core part of the MARE solution that connects telemetry, system characterization, policy constraints, orchestration logic and validation contexts for both proactive and reactive workflows. In short, the main rationale supporting the need for the sandbox resides on a key challenge, shared by both reactive and proactive approaches. Indeed, in a reactive approach, the question is whether a mitigation action is actually good enough once an incident has been detected. Similarly, in a proactive approach, the question now is whether a prediction is trustworthy enough to justify the deployment of preventive actions before damage occurs. In both cases, the real question is whether the action we are about to take has a better expected outcome than doing nothing, and this is exactly where the pre-assessment sandbox contributes through no action without preliminary testing, what if, an impact analysis of both attacks and responses. This slide shows the operational logic of the pre-assessment sandbox. A security function is first composed, then evaluated through PASTE, where the testing environment manager selects the most appropriate validation context and the pre-assessment and validation component checks whether the candidate action satisfies policy, performance, and security constraints before deployment. SSLA policies provide important inputs to this process, because MARE aims to validate whether a security action works, and whether it works under the right assumptions, with acceptable model accuracy, and with acceptable impact on the protected system. If the testing result is satisfactory, the action can move toward deployment. If not, the no action without preliminary testing and what if loops support refinement, alternative choices, and safer decision-making, demanding for the composition of a more suitable security function and starting the process again. The deployment of the proposed pre-assessment scenario supported by the sandbox strategy is challenged by three main issues. The first one resides on choosing the right environment where the pre-assessment should run, considering different security scenarios that require different levels of realism, controllability, and cost. The second issue deals with the effort to achieve an accurate and continuously updated digital twin, including topology, traffic, and relevant context, so that the sandbox remains a trustworthy replica rather going far beyond a static model disconnected from reality. Finally, the third issue is the model accuracy itself, since MARE must tune detection, prediction, and validation mechanisms to reduce false positives and false negatives and to make orchestration decisions dependable. To conclude, the expected outcome is a smart pre-assessment environment spanning simulation, emulation, and real infrastructure, where security services and functions can be analyzed and tested before operational deployment. This allows MARE to verify that a mitigation or prevention action is executed only when it is truly worth it, rather than assuming that every possible response is beneficial. It also enables the project to determine the likely impact of attacks and the likely impact of candidate countermeasures, which is essential for trustworthy and automated security management in future 6G systems. Thank you very much for your attention. This work is part of the MARE project, which is developing a programmable, modular, and disaggregated security plane for 6G ecosystems, supported by pre-assessment, orchestration, and validation capabilities. Please feel free to follow the project through the listed channels, and thank you again for your interest in MARE.